Hi, welcome to Essential IT and Security Skills. I'm Charles Redmond, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here. In this section, we're going to list different types of network security devices and explain how they can be used, define network address translation and network access control, and explain how to enhance security through network design. So as we begin this conversation, it's important to remember that not all applications are designed and written with security in mind. The network itself must provide its protection. Networks with weak security invite attackers. Aspects of building a secure network include network devices, basic network technologies, and the design of the network itself, all layered together to provide overall information security. So to understand how the different network devices and hardware provide security, you need to understand and start at the beginning. It all starts with the OSI model, or the Open Systems Interconnection model. This is how network devices are classified based on their functions. It illustrates how network device prepares data for delivery and how data is handled once it's received. The OSI model breaks networking into 7 basic layers. Each layer has a different networking task, and each layer can only speak to or incorporate with its adjacent layers, which is a fancy way of saying it can only talk to the layer above or the layer below. The 7 layers of the OSI model, from 1 to 7, are the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. To successfully navigate the Security Plus examination, you must be familiar with all 7 of these layers, their names, and their functions at each layer. So we will start with the hub. It is the most basic of all network devices. It's a layer 1 device. It connects multiple Ethernet devices together to function as a single network segment. They don't read data, they just simply pass it straight through. However, they're very rarely used today because of the inherent security vulnerabilities associated with hubs. That leads us to switches. The switch operates at the data link layer, or layer 2. A network switch connects network segments. It determines which device is connected to each port by its MAC address. They provide much better security than the very old and insecure switches. The network administrator should and must be able to monitor all network traffic. This helps to identify and troubleshoot network problems. There are 2 basic ways to do this, either by port mirroring or by placing a network tap, separate devices installed between 2 network devices. It's important to know and understand some of the more common attacks associated with these network devices, such as MAC flooding, or MAC address impersonation, or MAC spoofing, ARP poisoning, port mirroring, and network taps. Now, you could be asking, well, I thought you said that it's a good thing to have port mirroring and network taps. Well, it is, but because of the nature of what they do, capable of seeing and reading all network traffic in the segment, it can also be used against the network, so it's important to understand that it is a vector of attack and secure appropriately. Next, we have routers. The router will forward packets across computer networks. They operate at the network layer or layer 3. They can be set to filter out specific types of network traffic. Routers can also be used as load balancers to help evenly distribute work across the network and allocate requests among multiple devices. Some of the primary advantages of load balancing: it will reduce the probability of overloading any one single server, and it helps optimize bandwidth of network computers. Load balancing is achieved either through software or hardware devices. Some of the security advantages of load balancing is they can stop attacks directed at a server or application. They can detect and prevent any type of denial of service attack, and some can deny attackers information about the network itself by hiding, for instance, HTTP errors or removing server identification errors from HTTP responses. Next, we'll talk about some specifically designed security hardware devices, beginning with firewalls. The firewall can either be a hardware or software-based firewall. Usually, when we're talking about network infrastructure equipment, you'll find it hardware-based that will do inspection of packets. It can either accept or deny packet entry and is usually located outside the network security perimeter. When dealing with the firewall, it has three basic choices to make: either to allow, to block, or to prompt for action. Allow the packet to pass through, block or drop the packet, or prompt and ask what action to take with each individual packet. You have rule-based settings, which are a set of individual instructions to control those actions, or settings-based firewalls. This allows an administrator to create parameters of good and bad. Firewalls work on access control lists. Basic access control lists will identify a source, a destination, and a port and protocol. The Security Plus examination expects you to be able to identify and navigate and explain basic firewall access control lists, or ACLs. There are a couple different methods of firewall packet filtering. Either stateless packet filtering, which only inspects incoming packets and permits or denies based on conditions set by the administrator, or stateful packet filtering. This keeps record of the state of each connection and makes decisions based on the connection and conditions. Next, you have a web application firewall. This looks deeply into packets that carry HTTP traffic, like web browsers, FTP servers, and Telnet. It can block specific sites or specific known attacks, such as cross-site scripting or SQL injections. Next, you have proxies. Simply put, a proxy is nothing more than something that acts on another's behalf. In this case, we'll talk about proxy servers. It's a computer or application that intercepts and processes user requests on their behalf. If a previous request has been fulfilled, then a copy of, for instance, the web page that may reside on the proxy server's cache will be delivered to that requesting user. If not, the proxy server requests the item from the external web server using its own IP address. Some of the advantages of employing a proxy server are increased speed, reduced costs. By serving cached pages, it reduces the requirement to go outside of the network. This equates to less bandwidth required, and bandwidth costs money. Improved management. by blocking specific web pages or sites, and stronger security to intercept malware and hide clients' system IP addresses from the open internet. A reverse proxy operates in much the same way, except, well, yeah, you guessed it, in reverse. It does not serve clients, it routes incoming requests to the correct internal server. A reverse proxy IP address is visible to outside users, however, the internal server's IP address is hidden. Next, we have spam filters. Email systems use two basic protocols, the SMTP protocol, or Simple Mail Transfer Protocol, and the Post Office Protocol, or POP. SMTP handles outgoing mail. POP handles incoming mail. Spam filters installed with the SMTP server filter configured to listen on port 25. They then pass on non-spam email to SMTP servers listening on another port. This method prevents SMTP servers from notifying a spammer of a failed message delivery. Spam filters installed on the POP3 server are configured a little differently. All spam must first pass through SMTP servers and be delivered to the user's mailbox. This can result in increased costs in the form of storage, transmission, backup, and deletion. For this reason, a lot of organizations have outsourced to a third-party entity. This way, all mail is directed to the third party's remote spam filter, and the email is then cleansed before being redirected into the organization's primary network. Next, we have VPNs, or Virtual Private Networks. It uses unsecured networks as if they were secure. All data transmitted between remote devices and the network is encrypted. Two basic types of VPNs are remote access VPNs and site-to-site VPNs. A remote access VPN is what users are most familiar with. It goes from a user's computer across the internet to your primary internal LAN, where a site-to-site VPN will connect multiple sites to other sites across the internet. When employing a VPN, you will have endpoints. These endpoints are used in communicating VPN transmissions. They may be software on a local computer or a VPN hardware device. VPNs can be software-based or hardware-based depending on what the organization needs. Hardware-based generally have better security, while software-based are more flexible in managing overall network traffic. Next are internet content filters. They monitor internet traffic and block access to pre-selected websites and file types. Unapproved sites identified by URL or matching keywords such as gambling or sports. Next, you have web security gateways. These can block malicious content in near real time, blocking content through application level filtering. Some examples of this are by blocking ActiveX or adware or peer-to-peer file sharing. When choosing security devices, you must choose whether to take an active or passive role. Some passive measures include these firewall devices we've been discussing and internet content filters. The intrusion detection systems can detect attack as it occurs. It's important to understand that if you have chosen to take a passive approach, then you're choosing to monitor. And when you're monitoring, you need to choose a methodology. whether they be anomaly-based monitoring, signature-based monitoring, behavior-based monitoring, or heuristic monitoring. Anomaly-based compares current detected behavior with a known good baseline. Signature-based looks for well-known attack signature patterns. Behavior-based detects abnormal actions by processes and programs and then alerts a user who decides whether to allow or block that type of activity. And heuristic uses experience-based technique. Some call it learning. With intrusion detection systems, you have a couple different types to choose from, starting with the host-based intrusion detection system. It's usually a software application that can detect attack as it occurs on the local system. It monitors system calls and file system accesses and can recognize unauthorized registry modifications. The disadvantages to a HIDS or host-based intrusion detection system is it cannot monitor network traffic until it reaches the local system, and all log data is generally stored locally, which means you'll need larger hard drive space, which often can be equated to a larger and more expensive system. They are also extremely resource intensive and have a tendency to slow down the local host. Next, you have NIDS, or Network Intrusion Detection Systems. These watch for attacks over the network. NIDS sensors are installed on firewalls and routers and gather information and report back to the central device. Passive NIDS will sound an alarm, where active NIDS will sound an alarm and take some sort of actions. Now, these actions may include filtering out an intruder's IP address or terminating the TCP session. Generally, we associate these actions more with a NIPS, or Network Intrusion Protection System. The Network Intrusion Protection System, or Prevention System, operates very similar to an active NIDS. It monitors network traffic to immediately block a malicious attack, and NIPS sensors are located in line instead of on the firewall itself. The recent trend is for network administrators and network senior managers to purchase all-in-one type network security appliances, combining multi-purpose security appliances with traditional devices such as a router. The advantage to this approach is the network devices are already processing the packets, and a switch that contains anti-malware software can inspect all the packets as they come in. Next, we'll talk about some security through network technologies such as NAT and PAT. NAT is Network Address Translation. It allows private IP addresses to be used on the public internet. Well, kind of. It replaces the IP address of the private network with a public address. This is widely how we fixed, or at least put a band-aid on the problem of the diminishing IPv4 address space. PAT, or Port Address Translation, is a variation of NAT. Instead of using private addresses, it takes outgoing packets giving the same IP address, but a different TCP port number. The primary advantages of each are with NAT, it masks the IP addresses of your internal devices and allows multiple devices to share a smaller number of public IP address space. Next, we'll talk about Network Address Control, or NACS. It examines the current state of a system or network device before allowing a network connection. The device must meet a set of predefined criteria. If it's not met, the NAC allows the connection and then quarantines that device or system until the deficiencies are corrected. Some of the basic elements of secure network design will include demilitarized zones or DMZs, subnetting, virtual LANs or VLANs, and remote access configuration. A DMZ is a separate network located outside the secure and trusted production network. Untrusted outside users can access services in the DMZ, but not the internal secure network. Subnetting is simply taking an IP address and splitting it anywhere within its 32 bits. The network is divided into three essential parts: the network, the subnet, and the host. Each network can contain several subnets, where each subnet can contain multiple hosts. Subnetting improves the network security by isolating groups of hosts logically, not necessarily physically. It allows administrators to hide internal network layouts. To successfully navigate the Security Plus exam, you are expected to know and understand the advantages of subnetting and be able to explain and employ them in practice. Next, you have VLANs or virtual LANs. This allows scattered users to be logically grouped together, even if attached to different switches. They can isolate sensitive data to specific VLAN members, and communication on the VLAN happens through special tagging protocols used for communicating between switches. However, you will need to employ a router. In today's modern networks, you will not be able to avoid remote access, or working away from the office has become commonplace and accepted. Telecommuters and traveling sales representatives and traveling workers are an everyday aspect of the modern network. Strong security for remote workers must be maintained. Transmissions are routed through networks not managed by the organization. This is where VPNs and dial-up connections come in. They provide the same functionality as if they were a local user inside your office building. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.